Okay, Bismillah ar-Rahman ar-Rahim. Welcome to this second lecture for the Big Data Wrangling course. In the previous lecture, we have laid down the foundation for big data analytics. We have talked about the basics, the definition of big data. We have also talked about the technology stack for big data analytics. And we have also discussed the more problems, some of the basic problems that could occur in the data. We have seen what actually is big data and how can you recognize big data for your own company or your own setup or startup, whatever. We also saw the landscape. So we have seen how the landscape is changing very frequently since the last 5 to 10 years. So it's in fact, the change is so frequent that now it is getting confusing to understand the different offerings of big data. So big data solutions are basically offered in-house as well as on the cloud. So if you talk of Amazon Cloud or Azure Cloud, so these are I think the best cloud offerings right now. We also have Google, which has its cloud offerings, which is also very good. But as compared to Amazon and Azure, it does not seem that much extremely well developed as a complete offering of all the possible solutions. So, for example, you have real-time data as well as batch data. Okay, so real-time data could come from sources like IoT or any sensor data that you have is real-time data. Social network data is also real-time data. So the process of analyzing and processing real-time big data is different from the process and architecture required to analyze non-real-time data or batch data. Okay, so the cloud services are offering you very sophisticated solutions for processing, storing, analyzing real-time data. For example, Amazon has its Amazon Kinesis, Kinesis. We're going to be giving you an assignment to compare these solutions so that your perspective develops. So I'm sure there's a similar solution in the Azure cloud offering as well. So Amazon Kinesis is completely based on processing real-time data. It has nothing to do with batch data. So you could process batch data, probably. I have not used that, but it's meant to analyze the real-time data. And another perspective of big data is that you have a different breed of databases as compared to the relational tables that we saw in the last class, like Oracle and SQL Server. So that data there is being stored in tables. But I told you in the last class that now we have another generation of databases which are called NoSQL databases. And they allow you to store data in data structures which are not tables. So the problem about tables is that storing data in tables is pretty expensive. A table consumes a lot of space. Okay, it's like something tangible like a mobile phone that's like heavy. The data is as heavy as a mobile phone in your hand. And when you talk about the dust particles, which are just atoms, so that is how the NoSQL databases are storing your data. So it becomes that light. So with NoSQL databases, I can store with NoSQL databases, I can store larger volumes of data. Okay, larger volumes of data, and I can process them faster. So a table, like let's say I have a table worth 50 gigabytes. a table which is consuming 50 gigabytes in the Oracle or SQL Server might be stored just for maybe 500 megabytes in NoSQL databases. That the comparison is so strong. So NoSQL databases can store data in the form of JSON documents, XML documents, key value pairs, graphs. So the medium of storage is different as compared to a table. So when I store a table in the hard disk or the SSD, so that consumes space, but when I store it in a JSON document, that's peanuts. It's like comparing 1,000 rupees to just 1 rupees. Okay, so therefore with JSON and XML, etc., I can store more data, query it faster, and that is basically a solution for my big data problem. So therefore, the world is now moving towards NoSQL databases along with Oracle and all these things. So we cannot leave Oracle, because similar to the reason that we cannot leave Windows. Okay, if I tell you that stop using Windows, so there will be many companies who will not accept this proposition. How can we stop using Windows? Because Windows was a revolutionary product in 1990s. So anything which is revolutionary, you can't leave that so easily, Similarly, the Office suite that we use, Office and Excel and PowerPoint, that is also a revolutionary offering by Microsoft. We are still using it even after 25, 30 years. Similarly, we have the Oracle, the relational technology. So Oracle was the first one, then IBM launched DB2, then we had SQL Server, then MySQL, now Postgres. So these are all revolutionary products. So if a company is using these products for the last 10 years or 15 years, we can't tell them, okay, stop using this and shift to MongoDB. It's not easy, because MongoDB started in 2010. Although it has thousands of use cases probably, and it has been very successful in the industry. And I think people everywhere now want to use MongoDB, but still they will not leave Oracle so easily, because that is more stable. It is more secure. People have invested in it quite a lot. Oracle is a big company, a $1 billion company. The MongoDB, I don't think so. It's a $1 billion company. It's a child as compared to Oracle. Oracle is a huge giant. So therefore, we will keep on using the relational databases. That's the trend. But now when you have a big data problem to solve, you have to develop another infrastructure. That's what you have to keep in mind. And that infrastructure requires you to use NoSQL databases. Okay. So the solution can be offered either on the cloud or in-house. If you are sensitive about security, then okay, you can go develop an in-house solution. But if you're not sensitive about the security of your data and you are confident about the cloud, then you can move everything to the cloud or move your processing to the cloud. So you have to know the distinction between storage and processing. Storage means to store, process means to query and analyze. Okay. So all the business intelligence queries, data warehousing queries, SQL queries, all of them is processing basically. So that's the game right now. So I think there are thousands of companies which have already shifted to cloud, including the banks. But in Pakistan right now, we are not that much confident about the cloud. The financial sector is not confident. And because the financial sector is the most, you can say, the lucrative and the sector which has the most cash, the highest amount of cash flows and revenues and ROIs is the financial sector in Pakistan. The most successful business right now is the financial sector. So therefore, they have the money. If they have the money, they develop their own in-house solutions and their IT department is there. So they don't need to move to the cloud. Because when you move to the cloud, the problem is that you give the access to somebody else. Okay. So that's the situation. So no matter you go on the cloud or you develop an in-house solution, the point is that you have to develop the infrastructure yourself. You have to make a decision: should I use MongoDB? So Arif, can we have a mute? Okay, so you have to make a decision yourself. That's why you're taking this diploma, that you should be able to determine your big data problem in the industry yourself, and you should be able to design the solution for it yourself. So the solution is, first of all, what is the technology stack? How you are going to solve your big data problem? So in that case, you can have two possible scenarios. Either you go for a Hadoop implementation. For example, you say, okay, we want to first implement a data lake. If you are a big company or a big bank, for example, like HBL, I told you last time that HBL is going for data lake solutions. Okay, so you can decide to implement a small data lake if you want, or you can just say, we don't want a data lake. I will take data directly from Oracle and put it on some server where Hadoop is running. So a Hadoop cluster is running. So it can go like this, for example. So this is your Oracle, let's say. Okay. You have to excuse my writing here. And here, what you have is you have a big data problem. So what is the proof that you have a big data problem? Who's going to tell me? Let's say you are a business manager of a bank, Islamic bank. So what is the proof that you have a big data problem? Billion transactions. How can we have million transactions per minute? So what? Volume is increasing, so Oracle has enough space to store 50 terabytes of data. Volume is increasing, so what? So I can store everything in Oracle. I can store in Oracle if it is, even if it is terabytes of data daily, I can store in Oracle. What's the problem? Why is that a big data problem? Ji? Tasks. Which tasks? English, please, because this is being recorded. I don't understand what is the meaning of task. Transaction. You probably mean queries. Queries, right? But did you attend the last lecture? So we talked about SQL and everything. The SQL is the language for querying the data in relational tables. When you have data stored in tables, you want to analyze that data, right? You want to extract it to make charts and dashboards. That's why that's called analytics. So if you want to extract data from databases, there is only one way to do that, and that is through the SQL language. Okay, so SQL is a language with a syntax. You write statements to get the data. That is not the scope of this course, per se. Yeah, it's a query language, like you have Java, like you have Python. It's a language, right? So SQL is a language which you can use to extract data from the databases, which are storing data in tables, not NoSQL. SQL cannot run over data which is not in tables. Okay, so you can ask your IT department to tell you more about SQL language. So I'm still not clear that. Yeah. So Binish, thanks. Binish is saying that it's not only about storage. Storing big data is not a problem. Even if you are generating 1 terabyte of data daily, it's not a problem to store it. You can store it in Oracle. Oracle has so much space. Yeah, but if you want to analyze 500 gigabytes of data daily through SQL, SQL cannot query that much data. It's not, SQL can only run good, like maybe on several gigabytes of data at the most, or maybe several hundred megabytes of data at the most. But if you ask SQL to run a query over tables, which contain, let's say, 250 gigabytes of data, so maybe SQL is going to run very slowly. It's going to hang because it's not in its power to query a tables which contains so much data. Understand? There is no limitation of any software. The problem is that we have to select the software which solves our problem. There's no limitation of any software. Oracle is going to offer you services up to some threshold. But if the table size grows out of bounds, like one table contains, let's say, 300 gigabytes of data, which is a lot of data. Okay. And another table contains 400 gigabytes of data. And you want to merge these both tables in some query. Let's say we have a customer table and we have a sales table. So I want to run a query in which I want to calculate the total sales for each customer. So I have to merge both tables. Okay. So when I merge these two tables, that is almost equal to 1 terabyte of data. And now I'm asking SQL to query 1 terabyte of data. So SQL will run obviously, but it might hang. It might hang. It might take 3 hours, 4 hours. It might take 50 minutes. It might take 30 minutes. Okay. So that is not what you want. You don't have time to wait for you don't have time to wait for queries so much. So that the normal execution time for SQL query is just several seconds or several milliseconds for that matter. But those are small tables or small sizes. Okay. So like we can have something here. So this is customer table. This is sales table. So I can join these two tables through an SQL query. SQL query is going to join them virtually and then compute whatever you want to compute, the total sales per customer. And then, you can just show that on a dashboard in a bar chart. Okay. So the things you need to realize is that your current infrastructure, when does it reach its limit? That is when you have a big data problem. We can't say that, okay, if you have 1 terabyte of data, then you have a big data problem. We can't make any statements. If your analytics is being dragged, it's getting late, it's getting delayed, you can't run queries in real time. I want to, for example, if I am analyzing social network data as well. So social network data is a lot of data. So let's say my SQL queries are analyzing 250 gigabytes of data per query. So one query has to analyze a table which contains 250 gigabytes of data. And I have to run 50 such queries every day. Let's say that's the requirement from the business, right? So every query hangs by 5 minutes. When I run a query, I get the result after 5 minutes because the SQL is not that much efficient to run over big data. So that 250 gigabyte becomes a big data problem for me. But if someone does not have that much data, let's say your table size is just 1 gigabyte, and you're in SQL and it gives you the result immediately, then you don't have a big data problem. You can't say that I'm in gigabytes, so I have a big data problem. The big data problem occurs when the data management becomes, not just the querying, mind you, please. When the management of data becomes a problem, that, oh, I'm getting this, Danish told us about the volume of data. So the volume of data is increasing. I have to manage, I have to create new databases. Now, where should I do? How many databases should I create? I already have 10 databases on Oracle. Should I create another one, or should I run another database on MySQL. So there are several companies who have an Oracle installation, and they also have a MySQL installation, which is an open source database. So they are running 2 to 3 databases in parallel. So that's mismanagement. You should have just one single source of your data. If you maintain multiple database softwares, and each database software contains multiple databases, then how will you manage? Management becomes a problem. And then obviously, you know that when the data is coming raw, what does raw data mean? If the data is raw, then the data is dirty. So you have multiple databases, okay, spread over multiple database softwares. So what I'm trying to say is that, let's say this is your Oracle installation. This is your MySQL installation. So you have 2 database softwares. In Oracle, I have 10 databases. So one is, I have a customer database, I have a sales database, I have, let's say, a procurement database, a marketing database. I have different databases, and each database can contain multiple tables. Okay, and here, let's say I have 3 databases in MySQL. So in all together, I have 13 different databases. That's mismanagement. Okay, and the total number of tables across these 2 databases can be, let's say, 68. You get this point? What I'm trying to say is that Oracle is a database software which helps you create databases. Okay. A database is a unique entity. So one database is dedicated to storing one particular thing. So if I have a sales database, that is going to contain tables which only deal with sales, not anything else. Okay. If I have a customer database, that is going to contain several tables which will only store customer data. Okay. So let's say I have a database which is sales. In sales table, in the sales database, what are the tables that I can have? So sales are related to what? Customer. So a customer does a sale. So I have a customer table, product table, because when you buy a product, then that's a sale. And so that's in the product table. The price is in the product table. It's a column in the product table. We're talking about entities, customer, product, what else? That's all. Quantity, yeah. Quantity can be in this sales table. How much quantity was bought? And what else? We can also have a table for location, because sales always happens at a particular location. And obviously there is going to be timestamp. So timestamp will be in this sales table. So in this way, the sales database contains all tables related to sales. So I can have a database for marketing. Okay. And that is also part of my business. So marketing, which tables are related to marketing, for example? We can have a table for campaign. We can have a table for customers whom we are going to target for marketing. And similarly, you can find finance table, because marketing, yeah, advertising and digital marketing, we can have a table for which contains all those data related to SEOs and all those things which are done in digital marketing. So in this way, in one company, I can have multiple databases, and each database is going to contain definitely multiple tables. You can't have one table per database. Typically, you have multiple tables. Okay. So in this way, what I'm trying to say is that when you have a big data problem, what are the signs? The signs are that you have already one database software, then you need to use another database software. That's a makeshift. Okay, we are having this problem. Okay, let's download this and do that. We can't mess with Oracle, because Oracle is a whole ecosystem. Oracle is very sophisticated. I can't do runtime things in Oracle. It's stupidity to do it, because Oracle is a huge software with a large ecosystem. It has its security policies, user access policies. and there are many other things which you need to configure to use Oracle. So you can't just say, okay, I need to experiment with this, let's use Oracle. Okay, it's not that easy. So what I will download some open source software. So if I need to do something, let's say I need to analyze some data quickly, and Oracle, I can't do that in Oracle. So I will just download MySQL, put the data there, and run the SQL queries there. So in this way, this is an example of the fact that you are having now a big data problem. Okay, are you clear on this point? Okay, how things are. So when you start to use, when your number of databases starts to grow, you started with 2 databases, then on Oracle 3, 4, 5, 6, 7, 8, 9, 10, 12, 15, 20. That's too much. 20 different databases in one Oracle instance. That means that your data is increasing, volume is increasing quite a lot. So you need, that is definitely a big data problem. Yes. Again, the point is that the more data you have, the more difficult it is to query all of it to get all the information out. Data is gold. Data contains secret information that you want to extract. But the problem in big data is that SQL is not going to help you now. Again, then you need to move away from Oracle and MySQL, and you need to go towards NoSQL databases so that you can query large amount of data in one query. So in SQL, I can't query big data very easily. Do you get this point now? Is everything clear on this? That's the important thing. So if you don't make this decision after doing this diploma, if you don't make a decision to change, then you will never change. That's the problem of Pakistan. We have this huge problem that we can't decide. Our decision making power is not strong, and this is the reason that we wait for others to jump, and when we see that they are successful, then we also jump. Understand? That's the problem that we are facing. Yeah. Yeah. Okay, the point is that an attack can occur on your Oracle instance, which is very secure. It has its security policies. An attack can occur also on your NoSQL database. It is a fact that the Hadoop is not a very secure software. It does not have its own security framework like Oracle. It does provide some security, but it is not that much well defined as compared to Oracle and other softwares that we commonly use. However, the point is that if your Hadoop cluster is in-house, it is in your own company, right? Like Oracle is also running on some server machine. And similarly, your Hadoop cluster is also running on 2 or 3 server machines, for example. So you define your security with respect to the whole network, right? It's not just say, okay, I want to secure this Hadoop cluster. So the person who's going to hack or get in has to pass through several layers of security. So you define a security protocol for your complete system, and then maybe for some individual PCs or whatever. So if you don't have data governance, then it's quite possible that your data security practices are not extremely well defined, unless you have a cyber security specialist or some person from that domain who defines all the policy structure for you. But that happens basically under data governance. So data governance will ensure that the data is secure. If you want to secure your big data, then you need a data governance officer. You can't say, okay, the CIO is going to implement the Hadoop cluster and he will hire the big data people, and we are going to hire some other cyber security specialist who's answerable to whom. But if you have a data governance council, then both the cybersecurity guy and the CIO and the analyst are all answerable to the council, not just one person. Like when you create a job description, you define who you are answerable to whom. whom do you report to, right? You define it, right? Who is your reporting authority? So the reporting authority for these kind of situation is the Data Governance Council, not your immediate boss, because the council will know what is happening with the data all around. The data is not the problem of only the people who want the analysis. Data is the problem of every person in the organization. Either he's from marketing, operations, storage, procurement, delivery, whatever. Everyone is related to the data. So if you don't have a council, then if you are a big bank, or if you're a big retail company and you don't have a data governance council, then unfortunately, you're going to be facing a situation like this. You're going to have multiple databases. You are going to have huge data quality issues. There are no policies. How do you clean your data? How do you wrangle your data? How do you ingest your data with software? There's no policy. You just tell the CIO, yaar, ye kaam karna hai, and the CIO does it. That is not the way to do it. You need to have a policy for everything. So that the reason we are not adopting this is because we don't have a data governance council. We don't have anybody dedicated to that. So the data governance council consists of the highest C-level guy who is in your organization. For example, the big boss and all the C-level executives. The C-level executive of marketing, the C-level executive of procurement, the C-level executive of online banking, whatever. So all the departments, their heads are part of the data governance council. Okay, and obviously the CIO is also there. CIO is the most important person because he knows. So through the council, the CIO gets to know about what the business is thinking, and the business comes to know about what the data is. What are the problems with the data? Which data we are storing? How can we make use of that? So they exchange the knowledge, and therefore they will then design a policy which is unified for all. So the way to bring about a change here in Pakistan is to form the data governance council. There is no other solution. This because one-man show is just a one-man show. One-man show cannot, it's bound to go down sooner or later. Gee. No. Huh. Okay, that's a very good question. Your name, please. So Nasir Ahmed has put in a very good question. So he's asking that if we have Oracle, obviously now all of you know that we are not going to move from Oracle. Why we are not going to move from Oracle? Bataएं. If I have a big data problem, I know that I have to go towards Hadoop cluster or MongoDB or whatever. But I will not delete Oracle. Oracle will keep on storing my data. I will take from Oracle and give to NoSQL. But I will not mess with Oracle. Why? Sorry? So I can save it in NoSQL? No. Who is going to answer to this? Oracle is more secure as compared to NoSQL. So that might be an answer, but there is another answer. Why will not you shift? Why will not you delete Oracle? Let's say I have this, I decide to use MongoDB and I did all the analysis and I'm 100% sure that MongoDB is my big data solution. No, we can give them training. Why not suitable? See. Yes, that's the answer, that Oracle is a huge ecosystem. It's a giant, which is more secure and sophisticated for maintaining data as compared to a MongoDB instance or a MongoDB cluster. Understand? So MongoDB infrastructure ecosystem is not that much highly developed as compared to Oracle. And like the old adage that we have, old is gold. So Oracle is there since the last, it came into being in 1978 or 79, something like that. So like 40 years. People have been using Oracle since 40 years. The whole world has been using it. So it's not easy to shift from such a strong foundation. You are storing data in a database since the last 20 years. How can you shift to something which is just a baby? So you're not going to do that. Okay. So these things will be clear, because when we take the quiz, I'm going to ask you conceptual questions. They're not going to be theoretical questions. That what is MongoDB, what is Oracle? There will be conceptual questions. Okay. So now Mr. Nasir asked us that how we are going to make a shift. That's a very good question. Look, the first thing you need to do with data is to realize that which problem you are solving. Big data wrangling comes later. First of all, you have a problem. So what is the biggest problem that you can solve with data in the telecommunication sector? Vinish, telecom churn. Telecom customer churn is the biggest problem for the telecom sector. What about finance? A bank, online banking. What is the biggest problem in online banking? Yeah. So you want to ensure that no one hacks anybody's account. So you want to use data for that to prevent such an attack. What else in online banking? Huh? Online banking, risk management. How? Yeah, so I think these things are related. Risk management and the prevention of attacks, to detect fraud in real time, to detect any type of abnormal activity online in real time. You know, okay, if you have 3,000 customers from the bank and you analyze their online data, okay, and you know typically what they do. That's the analysis. आपको ये चीज पता चलेगी कि analysis is going to tell you what do the people typically do. What is the typical pattern? For example, on the average, they spend 10 to 15 minutes on the online portal. Most transactions are done in this category. On the average, this month amount is transferred. So you know these basic things from analytics. If someone comes in at 2 p.m., 2 a.m. in the night and transfers a huge amount online, he makes multiple transactions, for example, to transfer a lot of money, which is not possible, but let's say, just take a hypothetical scenario. Then that is an abnormal activity which you should be able to detect in real time, that what is happening. In the same way, credit card fraud can be detected in real time. So fraud detection, real-time fraud detection is a big use case of big data analytics. We saw in the last slide the verticals that we, okay. What about the insurance? What is the biggest problem in insurance? आप बताएं, you. Yeah, customers who are not paying insurance premium on time, how to get them to pay? First of all, you want to analyze why they are not paying. And when you discover the reason from the data, you want to discover the reason why they are not paying from the data. For example, what could be the reason of not paying? It could be related to some age group. So yeah, people of this age group are more stable in their payments, and this age group, they are not stable in their payments. So in this way, you want to find out different patterns, either by using BI charts or using some other analytics through Hadoop or Mongodb querying, for example. Okay. So that's the thing. What about supply chain? To some extent, supply chain, what's the biggest problem? Why real time? I can, if I'm going physically to some store, why real time? Real time is, So it's inventory optimization. I don't think anyone of you is from the supply chain side, right? So inventory optimization is the biggest problem, right? Which is related to manufacturing as well as the right quantity at the right time in the right location. That's inventory optimization, right? So it's not easy, it's a difficult thing. So you first of all identify the problem. Recently, we had a meeting with in IBA. We had a meeting with a very big company here, which is a, you can say, tourism related company. It's a big name. I will not name them. Okay. So they came to IBA, and I was of the opinion that they wanted some help in data analytics. So when my turn came to speak, so I told them some methodologies for solving their data analytics related problem. How will you do it? And when I finished, so they were looking a bit confused. They said that, oh, we do not know what problem we have. So I said to myself, then you should not be here. If you don't have a problem and you are making money, then why you are spending money in bringing us, gifts from your offerings? It's a wastage of money, because their policy is that if something goes wrong, then increase the subscription, customer tourist subscription, increase it. So increase by 50,000, increase by 1 lakh. So it's not a problem for them. And we always have people who are willing to pay in Karachi, at least. We have very, very rich people. So if the business does not see a problem, then there is no need to do any analytics. So whenever you go to analyze the data, the first question you ask is, what is your problem? So for that, you talk with the highest person is there, the business guys or the IT guys or whatever. But it's better to talk with the business guys. So my problem is that the quality of my data is very bad, because when I run SQL queries are not giving me, they're giving me garbage data because I'm not cleaning my data. That is also a problem. It might not be inventory optimization or whatever. Just say I'm running my SQL queries, but the garbage, I'm running SQL queries on garbage. I'm not cleaning the data. I'm not wrangling it. I don't know. I don't understand the data at all. So that is my problem. So yes, that's a huge problem. So I need to solve it, this problem. So the first thing you do is to identify the problem. Okay, because I'm answering your question basically. So when you identify the problem, then the problem relates to data. The business knows, you just have to make them realize. No one is going to do that. No one is going to hire. Why would they hire? The businesses are not, they will not spend money on analytics that easily. We will try to get the thing solved freely. And now IB is offering a good platform because I am the MS coordinator. So I have thought of a plan. If any company wants to implement any prototype, if they want to experiment with some solution before buying it or developing it, then we can get that implemented in our capstone project in Masters in Data Science and also Masters in Computer Science. So we can, that's a 1 semester project. So they can develop the prototype free of cost in that 1 semester. They will give you the prototype. You will experiment with that prototype, evaluate it. And if you find it suitable, then we can talk about developing a complete solution. If it is not suitable, then it's up to you. So because we want to give experience to the students, that's the main thing. Our purpose is not to get the money from the industry. If they want to develop a solution, you can also ask someone else. So this is the collaboration that we intend to have, inshallah. Baral, the first thing is to identify the problem. Okay. And then the problem is directly related to the data. For example, Binish has knowledge of supply chain. Okay, so she knows that I have an inventory optimization problem. She has the business knowledge of inventory optimization. So when I show her the tables, she will immediately know which tables are good for me. For example, she might not need a table for marketing. The marketing table has nothing to do with inventory optimization. She will need the table for sales. She will need the table for product deliveries, logistics, but not marketing or any e-commerce activity. Just giving a hypothetical example. Yeah, absolutely. Promotion. So promotion data, sales data, customer data, and manufacturing data, delivery data, everything that is related to inventory optimization, but not marketing data. Okay, so when you know about the business, so in fact, the first thing is to do this. Get the background knowledge. If you don't understand how the supply chain works, then you should not do analytics on that. So you might not be a supply chain person. For example, you might not have a degree in supply chain management, but you are tasked to analyze the data. So what I will recommend is that spend at least 1 to 2 weeks getting the data on YouTube, watch the videos to understand how a supply chain works. The YouTube is the best way to get the knowledge, because we don't want to read, we want to listen. So you can watch 10 to 15 different videos to understand how a supply chain works, and you're done. That's the best repository you can have for getting the knowledge. When you get the knowledge, then you ask, okay, what is your problem? Because now you have a good idea of how the business is running. Okay, so for example, if I want to solve, if I want to tell the marketing guys which people they should target. So they want to run a marketing campaign and they have a list of 5,000 people. And they're asking me to predict the top 100 people which I should target. So I can do machine learning to predict. Okay, but to do that machine learning, first I need to understand how marketing works. The mindset of the customer, what does the customer think about marketing questions? How does the customer normally respond? How do the marketing guys think? What sort of questions they develop? And so many other things. So if you don't get the knowledge and you jump directly into Oracle, give me the data, then you are just wasting your time. So the best person right now to deal with a supply chain problem is Binish, or the best person right now to deal with some insurance problem is someone who comes from the insurance industry, who has the knowledge of how the business is running. But if you are a third party and you're asked to help the telecom sector, so first you get the knowledge. That's going to help you 30 to 40%. It's going to boost, inshallah, your performance, because it gives you confidence, right? So get the knowledge, identify the problem. When you have the knowledge and you have the knowledge of the problem, then you immediately know which data I should be picking. So let's say this is the data that you want from Oracle. So this is the data which is you want to analyze to solve a problem. Obviously, I will not use all the data, right? So the first thing to do is to ingest. What is ingestion? So, okay, so let's say this is 250 gigabytes of data. And when I solve the same problem through SQL, then my SQL queries are hanging. Okay. So therefore we make a decision, yaar, ye iske bas ki baat nahi hai. Let's shift to some NoSQL solution. So we decide, how do we decide to do MongoDB? We are going to talk about this later. We have to develop a whole feasibility plan about it. Okay? But you make a decision that we are going to have MongoDB. So let's say this is another server machine. So you have this server machine here. And this is a separate machine, which is secure as well as the machine on which Oracle is running. And you install MongoDB on it and you are ready. But now what I have to do, I have to develop a road from here to here. Okay, that's obviously that's what I. Now what's going to happen? How that is going to happen? So I will have another computer here. That's a transit. Let's say a transit, okay? Like when you go from here to America on Emirates. So first you go to Dubai transit and then go to America. So it's a transit. So ingestion means to connect to a data source through some policy. And where will the policy come from? Data governance. So what sort of policies are related to ingestion? I have to shift my data from Oracle to MongoDB. And then I will run my queries on MongoDB, not in Oracle, not in SQL. SQL cannot run on MongoDB. Okay, I can't run SQL on MongoDB. MongoDB has its own query language. So there might be a converter. What is a converter? Converter means that there might be some software which is a layer over MongoDB. Okay, so I can give this SQL. So it's going to convert to a MongoDB query, run it, and give me back the result. Why is this a good solution? This layer. Why? I'm using Oracle since the last 15 years. I have written 200 SQL queries which I run every day. They are long queries. You know, it's a language. It's not easy to develop an SQL query. So it takes time to develop. Once you have developed it, then you save it. If you're telling me that there is no SQL in MongoDB, then what do I have to do? No. If I can't use those SQL queries in MongoDB, but I'm shifting the data to MongoDB, I still have to query that. So I have to develop those queries in MongoDB query language. MongoDB has its own query language. MongoDB does not understand SQL. Understand? So that work that I did in developing SQL queries, I have to repeat that work now to develop the same queries in MongoDB. But if I have this wrapper, then do I need to develop MongoDB queries? Tell me. No, because I'm just giving those SQL queries to the wrapper. Again, it's up to the wrapper. It is going to convert those queries to MongoDB. So I don't know whether there's a wrapper over MongoDB, but there's a wrapper over Hadoop. That's called Apache Drill and Apache Presto. Also Apache Phoenix. These are the three wrappers. I give them SQL. They will be converted to the query which Hadoop understands, those statements, and they're going to get the data and they'll give you the result. Yeah, Hive understands SQL. That's the, you can give SQL queries directly to Hive. We have to see, because does Hive follow the same SQL standard as Oracle? Because SQL has its own versions, 1.3, 1.4, 1.5. So is Hive compatible with exactly the same SQL standard as it? Typically, it should not be a problem. Hive understands SQL now since the last. Yeah, it's an interface. It's an interface. So this is a good thing. You can look up Apache Presto and all these things. So they are really cool. You don't need to do anything. The queries will remain intact. Okay. But what I'm talking about here is that I need to develop that pipeline. I need to develop a pipeline which takes my data from Oracle and puts that into Mongo. And that is not a one, is it a one-time activity? Is this a one-time activity or it has to repeat? Why continuous? Here it is increasing. Yes. New data is coming all the time. So I have to put that new data in MongoDB as well. So this is basically a rail track that you have to develop. Okay. So, and it has to be automated, because why would you do it every day yourself? Just automate it. Automatically, when that instance gets, when the Oracle gets updated, automatically the data comes to MongoDB. Now, Mr. Nasir's question is that how does this happen? So the first thing that you have to do is to obviously understand the background knowledge problem, then you identify the data, and then you develop the pipeline. To develop the pipeline, the first thing that you have to do is to ingest. What is ingestion? Huh? Collection? No. Huh? Intake. What is intake? Insert the data. Where I don't have any data, how can I insert it? The data is an Oracle. It's already inserted there. How can you? Through a torch? You have a software. You have to develop this pipeline through a software. You have to write code to develop this rail track. In the code, you will say, get the data from Oracle, do this, put this in MongoDB. And MongoDB is a database. It also has its format, although it is not a table. But it stores data in JSON. Have you seen the JSON format? JSON stores data in key value pairs. So I'll show it to you later on. So in which software will you develop this pipeline? In which programming language? In which programming language will you implement this pipeline? Python. Who else? Python. Answer given by, sorry, your name? Naseem. Mr. Naseem has said Python. Who else? Binish. Which language will you develop? MongoDB has nothing to do with that language. So, okay, a language is MongoDB understands and also Oracle understands. Oracle does not need to understand anything. I need something in between which takes data from Oracle. I don't need to make force Oracle to do anything. I need to connect to a database. You always connect. You make a connection to the database. Okay, so I'll just write that down. Yes. You need to connect to a database. एक second. PSX is stock exchange. Look, in the you need to understand how the stock market works. That's the background knowledge. How does the stock market work? What are the factors which can lead to a rise or a downward trend in stock prices? You can read upon that. What are the external factors which lead to different types of stock markets? Okay, so that's the background knowledge that you want to get. This I'm sure there's a lot of information on this topic. So before you start dealing with stock data, I think you need to first understand how the stock market works. and not just in Pakistan, but internationally how it works. So how does the financial all this industry uska jo usse ताल्लुक बनता है, तो how does it actually work? So you need to understand the process. How do these figures come up, and how do people invest in this? Okay, investment. What are the investment strategies, the trading strategies that people are following typically? So all these things are going to come in handy when you analyze the data. With stocks, the biggest problem is that you want to forecast. You want to forecast the stock price to a reasonable accuracy so that you can make use of that. You want to forecast economic indicators. So that's the biggest problem that we have in the stocks. Sorry?
No company is going to come to any data center and ask to identify our problems so that we can improve our sales and our revenue and the profitability. But the thing is, when companies goes to the consultant, they usually say, okay, we are stuck here and we are not moving anywhere and we are having decline of sales in our revenue. So kindly guide us, what could be the possibility we can get rid of this situation? Isn't it the same thing in terms of data?
If the company says that we are stuck here and our sales are dropping, so that is the business problem. Identify the problem means identify the problem in your business. Okay, the example that I gave, that we have a data quality problem, that basically translates to a problem of the business, because if your quality is not good, then it is 100% sure that your analytics is not good. And if your analytics is not good, then you don't actually know what is happening inside the data. You're not able to drill down to that extent that you want to. So for example, the business intelligence tools that we have these days, Power BI, Tableau, they allow you to wrangle the data as well. They allow you to wrangle the data as well, especially Power BI. It has many different wrangling functions that allow you to clean the data, develop your own columns, develop your own discretization of the columns, change the data in some way, remove duplicate values. So there could be like maybe 50 to 60 different operations that you can do in Power BI to wrangle the data, because they do, the BI tools understand that if you do not clean it, then there is no need to analyze it. So that is, this wrangling is 60 to 70% of the whole effort. It's really not easy. So 60 to 70% of the whole effort to first clean the data. And what did I tell you also last time? Wrangling means two things. First is cleaning the data, and second, understanding it. Understanding it through what? Statistical analysis. Through statistics. Statistics has been there since the last 300, 400 years. Understand the data, clean the data, and then understand the data. And the third thing, transform the data. Cleaning is another thing, understanding is another thing, transforming is another thing for analysis. So you can develop this pipeline in Python. Python is a language which can connect to Oracle. So like Mr. Naseem said, we have a connector. So we can use any database connector to connect to Oracle. And there is a database connector for connecting to Mongodb. Or both of the connectors are available in Python. So I have to write Python code. First, I connect to Oracle. I access that table which I want. That this red area in the Oracle. That's, let's say that 2 or 3 tables. Okay. So I get hold of those tables through Python code. I can also write the code in Java. I can also write the code in C#. But Python is more of a data science language as compared to Java and C#. They are more for enterprise development, like developing big products. They are not for developing big data pipelines. Any In Python, we can connect to hundreds of different data sources. Hundreds. There's absolutely no problem. I think SAP itself must be offering some connector as well, which we can import in Python and use that to connect to any SAP database. Because SAP has its own database, like Oracle has its database. So SAP has its own database. I think like HANA, I think is the database. HANA is not the name of the database. HANA is the analytics solution. ऐसे ही है. HANA database का नाम, I think it's something else. So ingestion means to do exactly this. Connect, and you have to do that according to a policy. What will be that policy? What will be the ingestion policy? Come on, start thinking. If you have to ingest data, what is the data governance policy? We already know what type of one. We have identified that. We know the tables. When should I connect? How much should I gather each time? Do I gather all the data in one go, or I take it batch by batch? And I also have to update Mongodb, like we discussed a few minutes ago. So each day, at what time should I make the connection? How much data should I get? And I also maintain the record. What happened last time? What happened last time? What happened last time? So ingestion means you need to connect to a database and then get the data from there. It has 2 to 3 different parameters which you need to identify in a data governance policy. So now you get the data. The data comes in the pipeline. The data comes in Python. Connection established. You get the data. Now what? Now what? Yes. Now we wrangle. And for wrangle, that is why I wrote this. I have another PC for that. And that is why we have a transit. Because wrangling is a wrestler. It wants its own space. Wrangling means that when you buy meat from the market or when you sacrifice an animal, right? So how you make the meat? Iske pie bana do, iske kofte bana do, iska keema bana do. Sometimes you do this, sometimes you do that. So when you are wrangling the data, the analogy is exactly the same. You need to cut your data, you need to slice your data, you need to delete it, you need to make its copies. It's all crisscross. You need to do many things when you're handling the data. So therefore, you need your own space. So it's better to dedicate another separate machine for that. And so in one company, you can easily dedicate one machine for wrangling. So the Python code might be running on this server which hosts MongoDB. The Python code. So that Python code connects to Oracle, ingests the data, and then gives the data to that machine in the center. You can do this in Python. It's not a problem. It's just a few lines of code. So now you connect to in the data, you stored that data in the hard disk there. And then what happens on this machine? Now you need to have a template. So I'll just write these things down. Ingest and ingest according to DG policies. Okay. So you ingest according to data governance policy. Then you put the data in W machine, which is the wrangling machine, let's say, or the wrestling machine. You can also call it wrestling. अभी जो आप hands on करेंगे उसमें आपको अंदाजा हो जाएगा why I'm calling it wrestling. ठीक है? Put the data in the wrestling machine or the wrangling machine. Or obviously you can store that in the hard disk or जो भी SSD है, जो भी whatever, that does not matter. And then you develop, बल्कि develop तो पहले हो जाएगा. Run the template for cleaning the data, understanding the data, and then transforming the data. That wrangling involves these three things. We talked about that, right? So here, okay, I'm just gonna. So ingest a code. Oh, sorry about that. Oh, sorry. How do you redo it? No, redo. Oh, thanks. So we just have to understand. What I'm asking you guys to do is, but do you know what's a template? Not not copy pasting. Sorry. Yeah, script you can say. Let's say we have a civil engineer. So a civil engineer is asked to develop a residential flat. So you bring that person and tell him that I have hired this place, so I am a property guy and I want to develop this apartments here. Please give me a plan. So he gives you a blueprint in 1 day. A sketch in 1 day. How can he make that in 1 day? No, not AutoCAD. In his mind, there is a template that whenever I have to develop a sketch for this, a blueprint for an apartment, then I follow this step. And he has learned that through experience. Okay. So like you drive a car, you have learned how to drive a car. So there's a sequence of steps in your mind. How do I drive a car? Do this, first do this, then do this, then do that. And then you're able to reach to another destination. Similarly, because wrangling involves many activities. Wrangling involves catering for missing values, deleting the duplicated rows, detecting outliers. That's a big deal. Analyzing your data per column, analyzing the spread of the data, understanding the relationships between the different columns, the correlations, the causations, analyzing the correlations through heat maps, changing the discretization of the data, changing the column names, merging two columns, breaking up one column into 2 or 3 columns. So at least maybe 50 different things. So I want to develop a template. A template consists of certain functions which have been defined already. Okay, so I will just call the function and use it. I don't have to write the whole wrangling code for every data that I get. Or the template is just that. For example, what is the template for a car? If someone is making a car, what is the template? A car has at least 4 tires. A car has a body, a car has an engine, a car has windows, a car has seats. That's the template. So they have the template, so they can use the template to make a specific car. Similarly, what I'm saying is that I will give you the template, inshallah, don't worry about that. Next class, maybe we have to start it. But that template is going to contain functions. They are going to help you. You don't have to write the code for anything yourself. You just have to call the function. For example, there will be a function for deleting duplicate rows. Just call that function, it will delete duplicate rows. So it's making things easy for you, in fact, because some of you are not from a technical background. Okay? So therefore, it's good to give you a template for doing things. Otherwise, you have to write the code yourself. वो भी आप कर लेंगे. I'm pretty sure कि आप you will inshallah manage that. But it is even more helpful for you to use a template, so that you can use that template for other tasks in your own career later on. Understand? So run the template. So when you run the template, then that is going to involve a lot of crisscrossing and a lot of function calling, lot of things going on here and there. Like for example, when you give a piece of cloth to a tailor, what does he do? the Caesar cut like this, do this, do this, do this, do that. And after 1 week, you have a beautiful dress. So that is exactly the analogy here. Wrangling is dirty work, but it is going to give you something which is useful for analyzing. Otherwise, there is no need. Okay. So once I have wrangled the data, then what? Now tell me, after wrangling? No, transformation is involving there. Clean, understand, and transform. All things are done. Everything is pretty good. And remember, this wrangled data is only for solving one particular problem that you targeted initially. It is not for solving all the problems of the organization. For each problem, you have to develop. No, database will remain the same. No. To solve each problem, you have to develop your own. You have to develop a new. थोड़ा generalize करें. आपके सामने solution है.
Query.
No. Yes, a new railroad. Because every problem has going to have its own data. The data for every problem is going to be different. I can't use the same data to solve all the problems. So if a company has 3 different business problems, so the data to solve the problems is going to be different from each other. So I developed 3 railroads to solve 3 business problems, and that is good. Why is that a good strategy? आप बताएं at the back. To solve each problem, I develop my own pipeline. Why is that a good thing? किस चीज का फोकस? एक सेकंड. किस चीज का फोकस? तो फोकस की जरूरत ही नहीं. फोकस कहां से आएगा? I develop one particular pipeline. You do understand what happens in the pipeline, right? Okay, you ingest the data, you clean it, wrangle it, and then you give it to MongoDB, and then you can query that. You can also build dashboards on MongoDB data. Okay, because MongoDB will have it. For 3 different problems, I develop my own pipeline. I have to develop separate pipeline to solve each business problem. Why is that a good thing? Why not have the same pipeline do everything? Huh? What overlapping? Yes. G.
Python so that I can run easy, so I can ingest faster data on MongoDB. And also it depends upon my DG policy, the data governance policy. When I want to run a complete data on MongoDB, or I want to run a data in batches. So it depends upon my data governance policy.
I think what we can take from your word is that I can run 3 in parallel to speed up things. That's one thing. G. No, accuracy can be increased. To some extent, that might be right. G, up. This pipeline is actually a piece of code. It's not a railroad or a track of a train. It's just an analogy that I gave. It's not something tangible. It's not a physical thing. It is just a piece of Python code in which I connect to an Oracle database. I run a template to clean the data, which involves a lot of work, seriously. and then I put the data, I take the clean data from within the code and give it, connect to MongoDB and give it in a particular schema, because MongoDB also wants data in a particular format, JSON. So I'm doing all of this in one particular piece of code, in one particular Python file. Is it okay? ये बात सही है ना? So there is the
I do have a question.
Sorry?
I do have a question, sir.
Just a second, please. Just one. So I have one Python file in which I do all of this. Now, it is not logical to use that same file for two different things. So if I have a different problem, I will create another file. I will create another Python file. So that means I have another railroad. So it is not even logically possible that I put everything in one Python file, because I can do it. There's no, I can make 6 different things, 3 things for the first, 3 things for the second pipeline. I can do it. But the point is that the dynamics of each pipeline is completely different. When do I transfer the data? Whom am I showing the analytics to? The client for first pipeline is different from the client of the second pipeline. The first pipeline could be for the HR department or the operations department. The second pipeline could be for the marketing department. The third could be for the sales department. So their needs, their preferences, their problems, their way of thinking is completely different. So it is better to have multiple pipelines in parallel, and every pipeline is basically dedicated to its own task and can run whenever you want it. For example, the marketing pipeline can run once a year or twice a year, while the sales pipeline will run every day, because marketing campaign is not a piece of cake, right? It's run over several months. So let's say I have 2 campaigns per year. So I have to transfer the data from Oracle to MongoDB twice a year. That's it. But the sales data I have to transfer almost every day. So how can I mix them up? So I have to write different pipelines for different problems that I have. That's the way to deal with that. Okay. Yes, finish. Yeah. No, that I will not. No, that is not preferred, because wrangling is also specific to your problem. You can, when you have a template, then what is the problem? I can repeat the wrangling steps. If 2 or 3 problems have 10 similar wrangling steps, so there's no issue. I have a template, so I can use the same template in each pipeline. Let there be repetition. But saying that we clean the data first and then divide it, that is also an approach that you can use, but I will not recommend it. What I will recommend is that you do everything for each problem completely independently from the other problems. You do not mix anything up. So, like for example, you tell me that there are some data entry errors. तो आप मुझे ये कह सकती हैं कि why you are catering for data entry errors in pipeline 1, then why do I need to repeat it for pipeline 2? Why don't we do it once, and then that is going to complicate the architecture? Because right now the situation is like this. Maybe after 2 months the situation changes. So the same strategy is not applicable to both the pipelines. So it is better to keep the pipelines completely separate. And in any big company, it is definite that you need to develop at least 2 to 3 different pipelines. One for the CIO, one for the marketing person, the other for the operations guy, the third for the inventory person. So there are different analytical requirements in an organization, and it's better to deal with them separately. Right now, the concept of pipeline is not there. Right now, what happens is that we have the Oracle instance, we run SQL, we get the result, and we show it to the, or if you're using BI, so the BI guys connect to Oracle, they clean the data in BI tools. So there's no concept of templates. Okay, so for example, I can import the data from Oracle into Power BI. So there's no pipeline. What's the pipeline? You just data. You don't have any policy. You just connect to Oracle and put the data in Power BI. In Power BI, you do all the wrangling, blah blah, which is not recommended, frankly, because Power BI is continuously updating and changing. So when you you want to do things in-house, so it is better to develop your own policy, your own way of doing things. You can wrangle in Power BI as well, but I think it is better to do everything in Python. Don't use the wrangling features too much of the BI tools. You can use them for exploration, but not permanent. It's not, I will not recommend it. Okay. So right now what we are doing in companies is the Oracle we have. On top of Oracle, we connect to Oracle, we put the data in BI tool, and then we make the charts. Mostly that is what is happening. There is not much focus on data quality or data. Data quality means data wrangling. When you wrangle the data, then you increase the quality of the data. So there's not a lot of focus on that. Okay, so that's the situation. So after wrangling, let me finish, and we have to take the break for prayers as well. After wrangling, you put the data in MongoDB in a particular format, which is obviously JSON, and that format is also called a schema. So database format is called a schema. So you have to design that schema as well. Obviously, if you are from a non-technical background, so you will hire somebody to do it. You're not going to do it yourself. So you can hire some fresh graduate or whatever, okay, from the CS side. And again, I'll just write it down in a different color so that it becomes specific, that you need to develop a separate pipeline for each problem. I'm sorry, there was a question online, so I will take that question when I come back from the break. My apologies, but I need to focus on the people here as well. So sometimes the concentration is not that much equally divided. So apologies for that. I'll take the question when I come back. Okay, is this thing clear now? Now, if I take a quiz in the next class, you should be able to answer all these questions. Ji. Sorry? Yeah. Hadoop is not a database. Yeah. I mean, Hadoop, you can consider it as database. The Hadoop database is called HBase. Yeah. Yeah. Hadoop, yeah, Hadoop is recommended. The only problem is that Hadoop's implementation is a bit more complicated than MongoDB. MongoDB you can just download and install for free. Hadoop is also free, but making a Hadoop cluster requires more effort. You have to write more code. You have to develop scripts for that. You have to automate things. So it requires more effort, and you need people who are more comfortable with the Linux platform, because typically all of this work happens on Linux when you work with Hadoop. But for a long-term solution, Hadoop is better than MongoDB. If you're a small company, then you can, and small company, e-commerce company facing a big data problem, then MongoDB is the best solution for you. There are also others, but currently you can say MongoDB. But if you are a big company, then Hadoop is thing that you should be doing Hadoop, because Hadoop is a better solution for big data than MongoDB in the sense that it has an ecosystem. MongoDB does not have an ecosystem. It is just going to store your data, and is going to help you query that. But Hadoop is going to help you develop tables over your big data, develop a database over your big data, process your data in RAM, do things like Apache Presto, run your SQL queries, and many other things. Many other things. Ji.
Long, like Python cannot be long and complicated script. So in MongoDB,
Python can write any length of script. Python is not a problem in scripting. Mahout is machine learning over big data, right? If your data is stored on Hadoop, it is distributed, and you want to use that for machine learning, so you need to have some sort of a mechanism to use that data, because it is not stored on one PC. Even if the data is on Hadoop and on one PC, it is in a different format. It is not in a table. So I can't use that like normally we use that in machine learning. Like if I have a CSV file, I will connect to a CSV file and I will start analyzing that and doing machine learning on that. This is just the small data case. In a big data problem, the data is not stored in the form of tables, either MongoDB. So in the case of Hadoop, you need to have a software which takes that data, puts that in a format which is understandable, and then uses that for machine learning. That's why you want Hadoop, Mahout. Yeah. So I can't run machine learning code of Python on Hadoop data. In Python, I can do machine learning. Python is the language for data science, right? I can do that. It's not a problem, but I cannot use that over Hadoop data because it does not understand it. Python understands CSV, Python understands Oracle tables, but Python does not understand Hadoop data. Yeah. I mean, it's a huge thing. We're going to talk about that later. That's not the focus of this course right now. Okay, Junaid is saying that, just want to add that the data source can also be different for each problem. It can be source system, can't we adopt the same schema from the source? Junaid, no, because the schema for MongoDB or Hadoop or any big data solution is different from the schema for tables. So if I store my data in Oracle, that schema is definitely different from the schema of any big data solution. The big data solutions don't work with tables. So you have to develop your own schema. I'll show you the examples when we come back. Okay, this is an example of a sales table. That's how it occurs in a database. So ये customer का table है, customer, staff, stores, orders, order items. This is how the table is designed. This is done by the IT guys, not by business professionals. What I'm trying to say is that in one database, you can have multiple tables. So here you have a sales database, which is consisting of 5 tables. And the tables are never independent. They are connected to each other. So for example, customer ka table, it's connected to the orders because a customer gives the order. And orders table is connected to a store because orders are related to a store. Okay. And then obviously we also have staff and other things. Similarly, you have a production database, which is consisting of categories, products, stocks, and brands. So in this way, we can have multiple databases spread over multiple tables. Okay. This is a SQL Server Database. So you can see here. So this is called a schema. Which tables and connected to which tables? A schema is exactly that. Which table are you designing, and how you are connecting that to the table. So that is how database is created. Okay. So over a period of time, this database starts to get dirty. In Hive, you can store the data in the form of tables. The same. Oracle SQL Server, it's all the same. I mean, you use tables. You have that primary key, foreign key. So because this is not a database related diploma, you just need to understand that we have databases, and in databases, in one database, we can have multiple tables. That's what you need to understand. Okay, जैसे ही आपको नजर आ रहा है. And one database deals with one thing, and one table deals with one unique thing. For example, I have a marketing database. What are the tables in a marketing database? Any? Talk about entities. Demographic is not an entity. Yes, a marketing campaign will need to market products. So I will have a product table. A product table will contain columns related to a product. What else? Sales history. The first table in marketing is going to be the customer whom you are going to target. And a customer is a separate table because a customer has a lot of attributes. Yeah, leads. So you can have like 3 to 4 different tables, okay, in a marketing database. So you can see the samples there. So you can say, for example, marketing database sample. So you can say schema. So here, what we have product type, and then we have open trace recognition, that is the product type. Then we have the, so this is not exact, this is not a employee invoice customer product. So this could be a marketing schema. Marketing is not really a very concrete example. So you can say, I don't know, e-commerce. We worked a lot in e-commerce. So this is, look, this is an e-commerce schema in which we have what's there, products, category, order details, orders, payments, customers. So sales ke table mein, these are the basic entities that we always have. Every business has sales, right? So these are the basic entities: customer, product, location, etc. So that is the thing. But when I talk of MongoDB, so let's talk of e-commerce MongoDB schema. So in MongoDB, I don't have tables like I told you earlier. We have documents, JSON, JavaScript object notation. So the way to store that is in this curly braces. And I told you that 1 terabyte of information in an Oracle table, 1 terabyte, an Oracle table which consumes 1 terabyte of space. That same information I can store in MongoDB in, let's say, half the size, or maybe 1/10 of that, 1/20th of that size even. So maybe just a few hundred megabytes, or just 1 to 2 gigabytes. Understand? So this is the way. So the relationships are there, but this is not a MongoDB course right now. So I can't focus on that. You just need to understand right now that the storing of data here is very, very efficient. Okay. Do you have any queries regarding the content that we have done up to now? Any query? We talked about pipelines, we talked about wrangling, we talked about ingestion, databases, schemas. Any query which is, anything which is not clear to you? A data scientist does not work with Oracle tables. Filling up the Oracle tables is the job of the IT department, because that is regular operational data which is coming every day. They are not analyzing it. They are meant to store it and secure it and run SQL over that. SQL is also an analytical language, but the analysis which SQL gives you is very weak. SQL does not give, SQL just gives, no, it is able to extract parts of the table for you. It does not analyze. Analyze means running some statistical functions, doing machine learning, prediction, forecasting. That is analysis of the data. Building the BI charts, building a data warehouse, That is called analysis of the data. But running an SQL query is not analysis of the data. So for example, let me just show you. So some sample SQL query you can search here. So let's say, what is this SQL query telling us? Select top 1000. ID, code, first name, last name, location from employees table. So this sample DB is the name of the database, and dbo.employees is the name of the table. So what is it telling you? कि employees के table से just pick the top 1000 rows and just show me those columns. That's it. How is this analysis? Is this analysis? I am just extracting a part of the table and showing you that. How is that analysis? That is not analysis. What will be analysis? If let's say I sum up something, or if I calculate the total sales, for example, sample SQL query total sales. So let's see if we can. Okay, now this is a bit complicated. Let me just go to this page. So this is a childish query, okay? SQL sum example. Now what is happening here? Select occupation. That means show me this table. So show me this column, sorry. Show me the occupation column. From which table? From the customer table. So a customer table contains occupation column. But what is the condition?
And they are renaming the columns as total income and total sales.
Okay, so this the output of this query is going to contain how many columns? The output of this query is going to contain how many columns? Two, 3. Who is saying 2, 3? Why 2? Why 2? Huh? What is it asking to select? And comma का क्या मतलब होता है? So it is asking you to select 3 things: occupation, sum of yearly income, and the sum of sales. So for each occupation, there might be multiple occupations, right, of the customer. For each occupation, show me the total yearly income and name that column as total income, and then show me also the total sales and name that column as total sales. So what will be the output? The output is going to be shown like this. So we will have a column, we'll have a table output as 3 columns. Let's say I have 3 occupations in total of the customers. So I will have 3 rows. In here, I will have occupation. In here, I will have yearly income. And in here, I will have total sales. So occupation 1, whatever the name of that occupation, occupation 2, occupation 3, and total yearly income, total yearly sales. Now, is this analysis? Why not? I am summing up, at least I am doing some sort of analysis. Totaling the KPIs is the first level of analysis. A very, very basic level of analysis. Like a child who learns how to walk. So this is not analysis which I require. I require analysis on BI charts and data warehouses, machine learning, big data analytics, deep learning. I want to be able to make forecasts. This is a very basic level of analysis. So the most SQL can give you is this. It can count things, it can sum up things, and it can select parts of the table and show that to you. But other than that, it can do nothing. So is it useful for analysis? So this is the reason that we are requiring the use of different technologies and platforms and Python and machine learning and big data, because SQL cannot manage big data, SQL cannot analyze the data. That is the problem. Okay, is this thing clear? These are the operations, na CRUD. Have you heard of this terminology? Read, update, delete, create, read, update, delete. That's what you do on databases. You create a table, you read the data from the table. Through what? How can I read the data from a table? Through SQL queries. Abhi dekha to yahi. I can update the row. I can update each row. For example, let's say my age changes. An year has passed to my age. So database में मेरी age, let's say 41 है or 40 है. So my age has changed today. So update that with 41. So I can update that row. And what do you mean by delete? Just delete a row. जैसे हम बात कर रहे थे duplicate rows को delete करने, तो ठीक है आप delete कर दें. एक customer है, he died. So delete. Maybe you don't need his record anymore, or maybe he did not give you enough sales and now he's dead, so we don't need to maintain his records. So delete. क्या ख्याल है? Is this thing okay? So database के अंदर ये 4 operations होते हैं. Create, read, update, delete. You create a row for a when you want to create a, for example, you get an order, you create a row for the orders table. If that order is wrong, if there is some corrupt data, then you delete it. So is this analysis? Create, read, update, delete. Is creating a row analysis? No. Reading data from a row analysis. I just select star from this table, show me these rows. Is that analysis? If I update a row, if I update the customer name, for example, is that analysis? No, obviously no. And if I delete a row, is that analysis? So this is what SQL does basically. Create, read, update, delete. SQL can create tables. SQL can read the table using the select statement that we have done. SQL can update the table. SQL can read the table or rows in the table. Nothing else. So therefore, SQL is not an analytical language. Okay. So now we have, I think we have talked about enough about these things. Now we can go to this. So in the next class, we're going to have a quiz over 2 lectures. And a quiz carries a lot of weightage for your final, in the final 100%. Honest students fail. Honest students are going to fail. Because how can I get there? We will think of some scenario, don't worry. Okay. So let me ask you a few questions right now. आप बताएं, when will you implement a pipeline in a big data scenario? Why will you need to transfer the data? No. Why you need to develop the pipeline in the first place? Why don't you run the queries on SQL and find out the analysis in a big data scenario? जी, आप बताइए. आप कपिल आप हैं जी, टेल कपिल टेल. Yeah. Why can't we do that in SQL, in Oracle? No, there is no limitation of storage. SQL is not an analytical language. Ji, Binish.
Need to make a pipeline to a database where you can easily analyze the data.
Yeah, so when managing your data becomes difficult, that means that you are having a big data problem and then you need to develop the pipeline. But that is not the answer. Everything is rightly said, but that is not the answer. Why? When will you develop the pipeline? When we have a business problem to solve. And for that business problem, you want to use the data. When there is a business problem to solve by using the data, then you see either we have small data or big data. If we have big data, then you need to develop a pipeline to transfer that relevant data from Oracle or any other database to some NoSQL database like Hadoop or Mongodb or Redis or whatever. There are many NoSQL databases: Redis, Ryak, Aerospike, Mongodb, CouchDB. There are many, several tens or several hundreds even. HBase, Cassandra. Understand? So when you have to solve a problem of business, because when you have a problem, then you have a client and you need to show the results of analysis to the client. Understand? That is the whole scenario that you want to keep in mind. Okay. So what are the 3 steps in data wrangling? नहीं आप नहीं, आप बताइए. Yeah. Cleaning the data. नहीं, वो cleaning में आ जाएगा. No. The template is going to help me with those 3 steps. Cleaning the data, number 2. Huh? Understanding the data through what? Statistics. Kapil is right. And number 3, transforming data. Why transform? What is the difference between cleaning and transform? Cleaning means to yeah, basically that's rightly said. Anything which seems erroneous to you, it's a logical sense that this is an error. It should, I mean, if someone's name is not written correctly or some product naming methodology is not followed, or there are spelling mistakes or caps mistakes, there could be many mistakes in the data entry. In the age column, we have some string. Okay, and in the product column, we have some number. All of these are data entry errors. So that is the cleaning task. We have missing values. Missing values, dealing with them is a huge cleaning task that you have to take care of. Okay, so that is the basic cleaning that you do. Like you clean the floor every day. Okay, or you dust your table every day. So that is the cleaning. After, when the data is clean, then you can understand that using statistics. Okay. Transforming means things like I have age in numbers, like 17, 18, 34, 48, age in numbers. I convert that to string, like young or adult or old. That is called transformation. Or I standardize my data to bring it in a particular range. Okay, so for example, let's say I have reading from IoT sensors, and I want to bring the reading from all IoT sensors in the range 1 to 100, so that they become homogeneous. You will see it later on why this is important, but right now just understand it. when you have numerical data, you want to bring that in the same range. The starting number and the ending number should be the same. That's called standardization. So in this way, there are different tasks which are called transformation. So we'll see all of these in the template, so you will then understand them better. Okay, so these are the 3 things that you want to do. Okay, so now we start with something which is a bit difficult, but you have to still understand that. So I'll just so let's say I'm looking at just one column. Let's say this is the age column. And age is occurring like this, that we have 18, we have 21. Let's say we have 34. We have again 32. And it goes on and on and on. And then we have somewhere here 56. So these are the age of the customers. I'm not talking about the whole table. I'm just talking about one column of the table. So what is the topic of this slide? Probability distribution. Oh, that sounds scary, right? So let me just give it a different color. So the first question to ask is, what is probability? Chances of? Chance or likeliness or likelihood. Okay. Although likelihood is another statistical concept, but just we can still use it. Chance or likelihood of something occurring is the probability of that event. Isko something ko call it an event of an event occurring. We call it an event. For example, some customer comes in the shop, that's an event. A sale happens, that's an event. A volcano erupts, that's an event. Okay, a new store is opened, that's an event. So the probability is the chance of an event occurring. And the probability always lies in the range 0 to 1. So the probability can take values only between 0 and 1. Obviously, if you multiply that by 100, you can say itne percent chance hai. Right? Is this thing clear? So now the next clause. What is a distribution? Distribution से क्या मतलब? Range of हाँ कुछ हद तक बात, to some extent it could be right, a range of sample. But let's try to discover something more specific. Segregation is also, you are in the right path, in the right direction. Yeah, you're getting more close. So let's write it down there. It's an indication of the spread of data. Okay. An indication of the spread of data. Okay, for example, if I ask you, what is the distribution of the vehicles which are passing this road? So you will tell me that I think 30% trucks are passing by in the last 1 hour, 10% buses have passed by, 55% cars have passed by, and the remaining is just cycles. That's a distribution, indication of the spread of the data, the variety, how the data is spread out. Okay, is this thing clear? Okay. So probability and distribution, we have seen them separately. And now, what is probability distribution? Nahin. Distribution of probabilities. Probabilities की distribution, that is called a probability distribution. Now, what is the message for us? ये आपकी wrangling की बुनियाद है. You need to understand this concept very clearly. I have this age here, right? 18. The first thing to do in wrangling is to realize that my data, is it reliable or not? जैसे हमने कहा था कि data entry errors, we have seen data entry errors. Data might contain some errors due to some other sources as well. The first thing you need to do in wrangling is to understand, is my data reliable or not? Numerical data. I'm talking about numerical data, not string. String data bhi hai, but it comes later down the line. Reliable basically means that it is something which I can use for analysis. Because data is recorded by external factors. Data could be coming from a sensor. Data could be coming from some other company. Data could be being entered by some human being. So all of these origins can generate errors. Okay. If my data does not follow the normal trends of how the data occurs, then my data is not reliable. Actually, what happens is that all the data in the world, especially the numerical data, I'm talking about the numerical data. And numerical data may be वो data that is related to your KPIs. That is related to your business. For example, the level of inventory, the number of customers coming in per hour, the amount of sales that is happening per day, the number of products that are being sold per day. Okay. The number of promotion items that are being bought on a daily basis, the age of the customer, the number of dependents a customer has. All of these things that we are dealing in the businesses on a daily basis follow some sort of pattern of occurrence. Understand? So that pattern of occurrence is basically something that we have to check. That pattern of occurrence is called the probability distribution. So almost all the data in the world that is being recorded, numerical data, follows one or more of the probability distribution. And probability distributions are fixed. We have a certain set of probability distributions, and all the data in the world will follow one or more of these distributions. Just try to understand that. I'll just write this down. The values in a numerical column, each value in a numerical column या KPI, because KPIs are typically numerical values, right? Each value is going to have a probability. That is the main thing you need to understand. For example, what is the probability that Kapil comes in the next class? 50%, depending on the government policy. In the same way, I can define a probability for each one of you. So for all the 15 participants in this class, I can define a probability. So there is a probability of coming for each of one of you. And that is a probability distribution. Okay. So in the same way, if I record the age of, let's say, 500 IBS students. So I have 500 values in the age column. So every age value is going to have some probability of occurrence. For example, 18 years, 19 years, 20 years, 25, maybe 18 years has a probability 30%. That 30% of the IBA kids have age 18 years. And 19 years has a probability 40%. 20 years has a probability 10%. 21 probability 10%. And the remaining more than 21 years. You get this? So the values of the age, every value of the age. What is happening here? Junaid, I think your mouse is. Every value of the age has a probability of occurrence. Now the main fact for you to understand is this one. ये चीज clear हो गई? So in this way, 18 has a probability, 21 has a probability, 34 has a probability. For example, let's talk about the final grades that we are going to get in this course out of 100. So one number is 100. What is the probability that 100 is going to occur? 0. Okay, 93, 94 probability is 2%. Maybe just 1 or 2 people can get it. The marks between 85 and 93, maybe 20%. Between 75 and 85, 60% maybe. But overall, the sum is going to be 1. Understand? So every KPI column that you have, the marks of the students, the GPA of the students, the age of the customer, the sales, the number of customers, the number of products, whatever. That column, the values in that column is going to have a probability. And the way, now this is the main that you have to understand. The way these probabilities occur always follows a particular shape. Okay. अगर मैं इन probabilities को plot कर दूं, if I plot these probabilities, they are going to follow a particular shape. That shape is called the probability distribution. In fact, that shape is called the probability density function, but that represents a distribution of probabilities. This is how my probabilities are distributed. So this shape is called probability density function. Now things should be clear to you. Sales, every value of sale has a particular probability. Overall, the sales column, every value has a particular probability. And these probabilities collectively should follow some standard shape, which is being defined by some probability density function. Density का क्या मतलब होता है? Concentration of values. Now, what are the probability density functions? There are standard density functions. The best and the most famous one is which one? Normal distribution. Okay, your probabilities are going to follow a bell-shaped curve. And this is, I think, true in 90% of the cases. Almost all the numerical data in the world follows the normal distribution. Any numerical data, geological, archaeological, operational, sales, marketing, mostly it follows the normal distribution. In other cases, it might follow some other distribution like Poisson, exponential, binomial, uniform, triangular. There are many distributions, many density functions. but primarily most of the KPIs of the numerical data follows the normal distribution. And we have many tests to ensure that, to check whether your data is normal distributed or not. Okay, clear? Is this thing clear? Yeah. Yeah, the graphical part of this is the density function. Distribution is a concept. Density function is a mathematical function which represents the distribution. Okay, that's the game. So if I ask you the age, okay, this age, the probabilities of this age column, if it follows a normal distribution, so the shape of that density function is going to be like this. It follows a normal distribution. So this is the reliability of the data. Okay, if the shape of my age column is like this, देखिएगा जरा. Is this a bell-shaped curve? ये bell-shaped है. This is not a bell-shaped curve. This is something which is very strange. Why the long tail? Why do you have this long tail? I just need outlier is the word. There is one person who has a very large age, maybe 88 or 98. He's a customer. The very, or maybe there are just a few customers. Out of 500 customers, maybe there are 10 of them who have an age 95 plus. They will skew your distribution like this. So just by looking at this, I can realize that, oh, there is an outlier. So the first thing to do is to see your KPIs in data wrangling. Look at your KPIs and see whether the distribution is normal or not. You can call it a normal distribution or a Gaussian distribution. Both names are used. It has a formula, but we are not going to go into the details of that. The main thing is the shape. Okay. What about this one? Is this a normal distribution? There are many tests which are going to say this is not normal distribution. We have some statistical tests. They will tell you whether your data is normally distributed or not. Just say Shapiro-Wilkinson test, Anderson test. So the Anderson test will say this is not normally distributed. Here it will say yes. Here it will say no. Here it will say no. So immediately when it says no, what is the next conclusion? There are outliers. They will not be that much pronounced. Let's say you know your customers are lying in 25 to 75. Okay, majority customers, 98% customers are having an age 25 to 75 years. Okay, now if someone has 77 years, is that an outlier? No. That is something which is very near to your normal upper boundary. Or if someone has 23, is that an outlier? No, I can't take the measure. Yeah, if someone has an age 5 years or 7 years, right? If someone has an age 93 years, is an outlier. So the definition of an outlier is specific to how you want to define it for your own business. For me, this is not an outlier. Outlier is someone, just say, we are dealing with, we are doing a project for Tabba Heart, THI. So they gave us the data for 5,000 patients जिनकी heart surgery हुई है. And in one of those cases, a person had a length of stay equal to 2,000 hours. 2,000 hours He stayed in the hospital. I don't know how many days that is. Many months. So that person is definitely an outlier because the average length of stay is just 7 days or 6 days maybe. So this guy is running into many months. It's an outlier. So if the average length of stay is 7 days, if someone has 10 days, then he or she is not an outlier. Understand? So you need to really understand. Yeah, you can single them out. Okay, yeah, they are not following my normal distribution. It is possible. So let me just look. Let me draw some graphs to. Oh, sorry. Control Y, you told me.
And this means that it can be organized there, but the data can be distributed normally also.
Yeah, वो गायब हो गया. Sorry. Yeah. देखिए, आप in your domain in risk analysis, it is very important to identify this. Okay, you do not just plot these normal curves. You also do the box plots. So that will make it more specific. In your case, we never have a perfect normal distribution on any KPI. It's never going to happen. What happens is that we can have something like this. Just a bit of a skew to the right side, or just a bit of a skew to the left side. So this is all safe. The problem occurs here or here. These are very serious type of outliers, which are fraudulent cases, let's say. In your case, you can say, yeah, in my business, even this thing is not acceptable to me. For me, it's an outlier. Single him out, will deal with them separately because of the financial impact involved in that. In the case of sales, we will say, ठीक है यार, चलता है. In fact, in this means that sales, someone has done a very big sale. If this is the density curve for a sale, for the sales data, then the right skew means that someone has done a larger sale, right? Positive side. So I'm happy. Why would I treat him as an outlier? I'm happy here, so you can say, ठीक है यार, जाने दो. So to really determine is my data normally distributed, I have this density curve. I can plot that in Python. Then I have the box plot. I can plot that in Python. And I also have the tests with me, which will tell me whether my data is normally distributed or not. So I can really, like, जैसे कहते हैं ना कि बाल की खाल हम निकाल सकते हैं. I can really drill deep and find out everything about my data. And this is part of the understanding phase. This comes after missing value analysis and cleaning. So I started off with this because this is the basic concept. Okay. Yeah, is this thing clear? Every KPI is supposed to follow some sort of probability distribution, which is formalized as a probability density function. Okay. And typically it is the normal distribution. And we have ample assessments to understand whether my data is normal distributed or not. Okay. So I'll just clear this and so let me draw the curve again. This is, you don't need to understand, you don't even need to understand this, but soon you can just hear it. So this curve has a formula, like I told you. This is the curve for the normal distribution. The curve for the exponential distribution will be like this. So the shape is going to be just like that. Okay. And similarly, there are different probability distributions and they have their own shapes. Okay. So they have their own shapes. Barhal, the density function is going to give you a probability in a certain range. So I will say, what is the probability that the age lies between 18 years and 25 years. I might want to find that out, right? What is the probability of my customers having an age in the range 18 to 25? I know the probabilities of individual values from the column, but when I approximate that using a curve, I can write such queries. So it becomes easy for me to understand my customer. So for example, if this tells me that the probability is 67, that means 67% of my customers have an age between 18 and 25 years. They're all teenagers or young people. Okay, so I can immediately make some promotion for these people. So that's what a density function allows you to do. But you will not be doing these things. आपका काम ये होगा कि you just need to check the normal curve and run those tests and see the box plot. That's your work. Okay. So now move on. Right. So here are some examples. This is the example for the normal distribution. So this is telling you that how your data is spread out. So basically, 68% of your data is supposed to lie within one standard deviation of the mean. Every column has a mean, right? Average value. Let's say the average value is 34 years. Standard deviation means how far are the values deviating from the mean. Okay, average, the more the data deviates from an average behavior, the less reliable it is. That is the main message of the normal distribution. If you deviate too much from the mean, if you deviate too much from the average behavior, that means that you are an outlier. So the normal distribution says in order to have this bell-shaped curve, 69% data almost is supposed to lie within deviate just one standard deviation from the mean. Standard deviation is a measure of calculated deviation, that number minus the mean. That's it. How far I am from the, let's say, isko is tarah samajh lein ki I am just one step away from the mean. So 68% of your data should comply with this rule. If your data has to form this normal curve. The next rule, 95% of your data should lie within 2 steps of the mean. So 68% rows should lie within 1 step of the mean. यानी उनकी जो value हो, वो mean से just deviation 1 step हो, very close to the mean in fact. Okay, and 95% of data should lie within 2 steps, and almost all the data should lie within 3 steps. If it exceeds that, then what happens? Then it becomes to skew. So you never have this perfect normal curve. There is always a skew. But we make some compromises. In the case of finance, we can't make any compromise. So we'll have to categorize even a single strong deviation as an outlier. But in the case of sales or the number of customers or the number of visits per customer, we can say, yeah, okay, this is not an outlier. It is a skew, but we don't treat that as a skew. We say, okay, koi masla nahi, jaane do. Don't separate the case. Clear ho rahi baat? Is this thing clear? So these 3 rules are just there to help you understand whether your data is reliable or not. You are not supposed to calculate these probabilities. You are just supposed to see the shape. You'll see the shape, you'll see the box plot and make a decision. Okay, you can also detect outliers. It is not difficult. Okay, this is the shape of the Poisson distribution. Poisson is fish actually in French. French में Poisson को fish. French में fish को Poisson कहते हैं. But in this case, Poisson was the name of some guy. So the type of data which follows the Poisson distribution is a bit different. Poisson distribution में वो data आता है कि how many times something is going to happen in a particular time interval. For example, in the next 15 minutes, how many customers are going to enter my store. That is a Poisson distribution. That is not normal distribution. That will not follow the normal distribution. In the next half an hour, how many cars are going to pass by this road? That is going to follow the Poisson. The shape is going to be like this, not necessarily normal. So Poisson distribution has its own formula. And what is the distribution here? Which one is this one? The third one here down. Exponential distribution, because the exponential curve goes like this. So different types of data are going to follow different types of distribution, but typically almost all the numerical data follows the normal distribution. If some data is not giving you a normally distributed curve, then that means that possibly it is either it is contain a lot of outliers or it follows some other normal or some other distribution. So the use cases for Poisson and exponential and uniform and binomial Bernoulli are very, very few. You will hardly find them in your data. The data that you deal in finance, and mostly it follows the normal distribution. I don't know about stock values, frankly. I don't know how stock values are occurring. So you have to see whether the stock values, is it following a normal distribution? Do the stock values follow a normal distribution or not? Check करें अभी जरा इसको Google करके देखें शाबाश. Convert them into logs. Log, अच्छा, yeah. But yeah, that's because they are not the regular business data. The stock values are getting influenced by many external factors. The normal distribution happens when you are more into the business data, like sales, hiring of employees, expansion of your business, merging with some other company. All the variables related to these things, they are all typically following the normal distribution. But stock is something which is being affected very much by what is happening outside. The market and the conspiracies and natural disasters and economic condition, GDP, all of these things are affecting your stock values. So you don't have it's very difficult that a stock value maintains a normal curve. That is my guess. I don't know. You should investigate this. The log returns because the log transformation is a very strict transformation. It is supposed to happen, but typically we don't do it. We do it in time series forecasting. So yeah, in time series forecasting we do cater for stock as time series forecasting. So yes, we can do it, but you should investigate why it does not follow the normal distribution and which distribution it follows. You can ask Google and find out yourself. So I think we have done enough regarding distributions. Okay. All of you are comfortable with Anaconda Navigator, right? You have downloaded that, right? Jupyter notebook, na? We will. Notebook mein run kar lenge na? I'm going to give you some code in the next 1 or 2 days. You just have to import. You just have to open that file in Jupyter Lab and run the code regarding what we have read today. Okay. You just run the file. I said. So we'll do this box plots and then we'll finish. Okay. How many of you already know about box plots? No one? Kapil, who else? Finish? Who else? This is the box plot. Now, what is a box plot? Let me draw the normal curve on that. सही है? A box plot is just a cross check on your normal curve. The box plot that you are seeing here, the major part of the normal curve lies inside the box. The whiskers are basically representing the spread of the data. The blue lines are representing the whiskers. It is called a box and whisker plot. A box and whisker plot. Okay. IQR is representing your majority data that is making your normal curve reliable. Basically, the things that you have inside the box is what is making the curve of your normal curve. Okay, so that the box plot that you're looking at right now is synonymous to the normal curve above it. The box contains majority of your column data. ठीक है, आपके कॉलम में जो डेटा है वो ज्यादातर बॉक्स के अंदर लाई कर रहा है. यानी if I make the box here, अगर मैं यहाँ पे बॉक्स को, if I make the box here, how will you make the box for this curve? Here, let's say I start the box here, I finish it here, and the whiskers are here. There is hardly any outlier. So you can say the box represents the central 60% or 70% of data. That is one step away from the mean. So this is a perfect shape. Okay. Now let's say I have this normal curve. Can you draw the box for this? Huh? The box is going to be something like this. A very small box here. And then a long whisker. So that is going to show you something is wrong. The box needs to have a healthy shape. If the box is small, then that means definitely outliers are there. Okay. So abhi itna mere khayal mein hame abhi, we don't need to move in that much detail here. IQR and all these things. IQR is the thing that is one step away from the mean. That is IQR, interquartile range. What is the central line? The median. What is the difference between median and mean? A median as the central. ये तो आप लोग पढ़ लें यार. Even from a non-technical background, median की definition तो आनी चाहिए. You should know. Huh? The central two values or the central value, that is the median. And mode, most repeated value. So in the box plot, the central line is the median. And what is it written? Q3, 75th percentile. What does that mean? Q3, Vinesh is saying that this means Q3 is a number. Q3 is a number. So let me put some numbers here. Let's say this is, I'm talking about the age. So I have an age which is, let's say 7 years, 8 years. And this is, my customers are starting actually, let's say from 14 years. So the reliable customers are lying in the range of 14 to 75. And this is, let's say 88. And this is 89. ये बॉक्स प्लॉट की जिम्मेदारी है कि वो आपका आउटलायर्स निकाल के देगा. The box plot is going to calculate the outliers itself. It gives a formula. So let's say Q1 is 28. Q3 is let's say 38. मिसाल है, just an example. What does it mean कि Q3 is 38? What does it mean? Yes, 75% of my customers have an age below 38. That is what a percentile means. That's a big deal. Okay. And 25% of my customers have an age below 28. And how they're calculating the outliers? The maximum value is calculated as Q3 plus 1.5 multiplied by IQR. ये एक बेसिक फॉर्मूला है जो कि पुराने जमाने से इस्तेमाल होता हुआ आ रहा है कि the maximum value is this, the bar, the whisker, where the whisker is finishing, that is maximum, and the whisker that is finishing there, that formula is also written. Anything that lies beyond that or after that is called an outlier. Yeah, in our case it is 10 because I have done hypothetical values. So whenever you draw the box plot on Python, it is going to show you the outliers itself. Maybe it is based on this formula, maybe it is using 1.6, maybe it is using 1.4. I don't know, but typically 1.5 is the standard. Okay, is this thing okay? So now we can just finish the lecture and so these are the different box plots. So you tell me what is happening in these box plots. I have done 4 experiments with 4 different values. You can see that the data is primarily, what is your conclusion regarding these 4 colors? What is the first conclusion? That the data for these 4 experiments is it normally distributed or not? Why? भाई माफ कर दें, सारा data, all the data is lying between the whiskers. There is no outlier. The first conclusion is that in all the 4 experiments, there is no outlier. So your data can be categorized as normal distribution, but because the shape of the boxes is changing, that means that some sort of skew is there. You can see that none of the boxes are ideal. Something is very small, something is very large. There is no ideal size of the box. Are you looking at that? Is this thing clear, right? So the size is not ideal. Look at the purple one. It's such a long box. So why we have plotted these 4 together so that we can compare them. So you can say in experiment 1, I think the best box that we have is probably for experiment 1, because the whiskers are balanced on both the sides. The length of the whiskers is balanced from both the sides. You see, that shows you that the skew is almost the same from both the sides. So that is well balanced. The only thing is that the curve is a bit spread out. It is much fatter. ठीक है, ये थोड़ा सा curve इसका fat हो गया है. That is the thing. देखिए, all these 4 distributions are normally distributed. There is no very large skew to give an outlier. Now see here what is happening. This curve starts here, goes a bit here. The tail, like I told you, it's a bit fat. The tail is not very strong here because you can see there's a concentration of data here, which is giving you this part of the curve. In this case, I think it's going to go like this. And then it is going to go like this. I think that this curve is much better because the peak will happen where the data is. The data gives you the peak. Okay. In this case, you can see it is spread out because the data is occurring, and then it goes down, and then this could be a multimodal distribution in which I have 2 peaks. Could be the case. This is called multimodal. In this case, it's sort of spread out like this. So none of them is absolutely normal, but as there are no outliers, as the software has not detected any specific outliers, so we can't say that data is not normally distributed. It is not even skewed. The only change is that the shape of the bell is very, very strange due to the spread of the data. For example, in experiment 1, you can see the box is empty in the center. That is something which is not good. Similarly, the same thing for the blue one, the same thing for the purple one as well. The box is a bit empty towards the center. So that means that data is occurring either on the left side or on the right side. There's a concentration, but the main data that makes the perfect shape of the bell is not there. So then now we have to investigate why is data occurring towards the sides. That could show you some behavior of the customer or whatever. So maybe these are last minute sales or something like that, early morning sales or last minute sales, you know. So even looking at this box plot is going to tell you a lot of things about the customer behavior. For example, let's say this purple one represents the sales, daily sales. So my daily sales box are like, what does this tell you? What can you conclude from the purple box plot? I don't have any average sale. Either my sale is going towards the high side, or my sale, either cheaper products are being bought, very cheap products, like maybe you can say a very small book or something like that. Maybe it's something worth $2 or $3 or $4. A small gadget worth $3 or $4 or $5, something like that. And or maybe something is being bought like a $70 book or a $90 book. So we don't have that much of an average behavior. Understand? Because the fact that this area is not consisting of fewer data points as compared to this area or this area. And the same trend can be observed in red also and blue also. You can see. Understand? So that is how the sales is happening. That is what the customers are doing. For our case, we can say, I will say the data is somewhat skewed, but I can't say that it is not normal. It is normal because the box plot is telling you it is normal. The shape is horrendous. Okay. So that's the conclusion. And you already know about this. So upper fans and lower fans, 25th percentile, median, outlier. Now in this case, you see, in this case, we do have the outliers. Understand? So we record the data at 12 o'clock, then at every 5 minutes, we make some observation. So after 5 minutes, we record some reading. So the data is pretty normal for all the timestamps, except those outliers. So now this is very interesting that in every time interval that you record the data, most of the data is almost exactly the same. The median is the same, the shape is the same, the whiskers are almost the same length, but there are outliers and significant outliers. Okay, so this is immediately you can ask Python, okay, what are the values that are above? This is the temperature reading. So whenever at every time you can say that some temperature readings are really, really high on the negative side. Towards the positive side. So the median temperature seems to be -17, but some readings of some things are going towards 0. So it has to be seen that kaun sa experiment kiya gaya tha, what does this imply? So in this way, you can interpret lots of things about your data. Imagine your data having 7 columns, numerical columns. You make 7 plots, 7 box plots, 7 distribution plots, and these 7 charts are going to give you so much information. Understanding about your data, what is happening to my data. Okay, but obviously this comes after you have catered for the missing values. Once we clean the data first. Okay. So in the next class, you're going to have a quiz over these two lectures, and just stop the recording.